In this video, we are going to talk about ratios and rates, and we're going to start with ratio. A ratio is a comparison of two quantities that have the same units. We could write it in three different ways. We could write them in terms of fractions, so we could compare the numbers 2 and 3, so we could write it as 2 over 3. We could think about it with a colon between the two numbers, so 2, 2, 3, or we could write it using the word 2 instead of the colon there, and write 2, 2, 3. So let's look at an example. Survey revealed that on average, adults age 18 to 24 use social media about 3 hours per day. We want to find the ratio as a fraction in simplest form of the number of hours spent on social media to the total number of hours in a week. So we're comparing in terms of a week. We know there's 3 hours per day. 3 hours per day. So then how many hours are there in a week? So if they're doing 3 hours a day and there's 7 days in a week, then that would be a total of 21 hours per week. And that's spent on social media. So that's going to be our numerator. And then it says 2, which means now we're talking about the denominator, the total number of hours in a week. So the total number of hours in a week we know there's 24 hours in a day times 7 days a week. So if I multiply 24 times 7, that gives me 168 hours in a week. So then my ratio would be 21 to 168. And then we're going to reduce this. We're going to see if we can find numbers that go into both of these. So 21 is 3 times 7. And then 168 is divisible by 3. And 7. So I just broke it down into what I can multiply 168 by. You can see how those 3's are going to reduce and those 7's are going to reduce. So we're going to be left with an understood 1 in the top and then 8 in the bottom. So our ratio here is going to be 1 to 8. A unit ratio is a ratio in which the number in the denominator is 0. One situation where we might want to think about that is student to faculty ratios. We can also do this when we compare prices in the grocery store. Maybe we're looking at two different sizes of a shampoo bottle and we want to know price per ounce. Let's look at an example. In a recent year, UCLA had approximately 31,500 undergrad students, 14,300 grad students, and 7,800 faculty. We want to find the ratio of students to faculty as a unit ratio. We're going to round to the nearest whole number. So let's find our total number of students. So we've got 31,500 undergrad, 14,300 grad. And if I add that together, I've got 45. I don't know what's going on with my tablet. Sorry about that, guys. 45,800 total students. So I want students to faculty. So students to faculty. And we're just going to divide that out. I'm going to do that on my calculator off screen. So 45,800 divided by 7,800. And I got 5.87, which is approximately 6. So we would think about this as 6 students to 1 faculty. So let's look at another example. Let's say we are in the grocery store and we are looking at shampoo prices. And actually just pulled this off of Walmart's website. They have a 27.7 ounce for $8.97, and they have a 10.4 ounce for $4.47. And we're asking which one's the best buy. So we're going to find the unit rates for each. So to find unit rates, it's going to be price per ounce. So we're going to take that 8.97 and we're going to divide it by 27.7 ounces here. And then we're going to take the 447 and divide it by 10.4 here. So 8.97 divided by 27.7 is going to be 32 cents per ounce. And if I take 447 divided by 10.4, this is, and I'm rounding the two decimal places since we're talking about money, so 43 cents per ounce. So the better deal is going to be the one that's the 27.7 ounce. So I'm paying less per ounce for each of those ounces. Now let's talk about rates. The word rates used a lot. It's really just a comparison of two quantities. We talked about unit rates in the previous example. To find a unit rate, we divide the number in the numerator of the rate by the number in the denominator of the rate. So this is really similar to what we just did. A dental hygienist earns $13.04 for working a 40-hour week. We want to find the hourly rate of pay. So we're going to take that $13.04 and we're going to divide by how many hours. So 13.04 divided by 40 is going to be $32.60 per hour. So that's her hourly rate. Another application is the cost per unit of measure. That's one that we just did a few minutes ago. Which is the more economical purchase, an 18-ounce jar of peanut butter priced at $2.69 or a 28-ounce jar of peanut butter priced at $3.99. So again, we want price per ounce. So we've got $2.69 for 18 ounces, and then we have $3.99 for 28 ounces. $2.69 divided by 18, I got 0.15 when I round to the hundredths place value, two decimal places. So that's per ounce. And then $3.99 divided by 28, I got 0.14 ounce. So the better buy is going to be the larger one. That's not always the case. It usually happens to be that way, but not always. Rates such as crime statistics or data on facilities are often written as rates per 100 or rates per 1,000 or even per 100,000 or per million. So we don't always think about it in terms of per one item. Let's look at an example. In a recent year, there were approximately 1,200,000 violent crimes in the U.S., given that the U.S. population in that year was 310 million, and we want to find the rate per 100,000, and we're going to round this to the nearest to the nearest whole number. So let's start out by finding that unit rate. We've got 1.2 million. And this is crimes per 310 million, which is the population. So that is 0.00387 and some change. And we want to find the rate per 100,000. So let's multiply that, because that's a unit rate, by 100,000. So I'm going to have 0.00387 times 100,000. And that's going to give me 387. So our violent crime rate in this case was 387 per 100,000 population. Another application of rates that we see is in the area of international trade. So suppose there's a company in France that purchases a shipment of sneakers from an American company. Then we're going to have to convert back and forth between the two currencies. So we've got an example of exchange rates on this slide. We've got the British pound. This is per US dollar. We've got euros, Japanese yen, and Canadian dollars. So let's look at a few examples. A, suppose that a Japanese company places an order for iron ore that costs 20,000. What's the cost in Japanese yen? So it's going to be 20,000. That's US dollars. So I'll say USD. And the the Japanese yen down here, there's our conversion rate. It would be this per US dollar. So it would be 113.266, and that's in yen per, so that's your divided by 1 US dollar. And then we just multiply fractions. So we've got 20,000 times that 113.266, and then we're going to divide it by 1. So 20,000 times 113.266. I got 2265320, and when I divide it by 1, I'm going to get that, oops, 2,265,320. Let's look at that next example. An American tourist purchases a vacation back package for 3,125 pounds. We want to know the cost of the vacation in US dollars. So we've got 3,125 pounds. We're going to multiply by the conversion rate. So now we're using this one. So this is pounds per dollar. So we know $1, so USD, $1 is equivalent to 0.77368 pounds. So notice the way that I set this fraction up. I set it up so that those pounds are going to cancel, right, when I multiply fractions. And then I'm just going to multiply fractions straight across. So it's going to be 3125 times 1, which is 3125. And then I'm going to divide that by the 0.77368. So 3125 divided by 0.77368. I got 4039.14. So there's my price for that vacation package in US dollars.